I will open the next slide for you. Okay. Can you see the slides?
Yes, Victor, yes.
Now, we want to discuss about the synthesis methods or synthesis strategy. We have two main synthesis strategy. First one is top to down. Second one is down to top. Uh, and there means that uh, where you start your work. You start from the small particle, small atoms, and form nanoparticles, or you start from a big piece of material and put it down to particles. So if you do chemical reactions to grow your nanoparticles from atoms and ions, it's called down to top or bottom to top. And if you reduce the size of a big material to nanoparticle, it's called top to bottom. Okay. So today, first we are going to discuss the top to bottom approach, the methods which are based on the reducing the size of the big material. Imagine you have a big piece of material and you crush it or you somehow mashed it in small pieces. One way, which is very old technique for making particles, is grinding the particles or milling process. So you can grind the seeds, the wheat, the barley, and have flour, and you can make bread from this. Okay, but the point is that this old technique is also changed with the technology. The new machines called ball milling. You can do ball milling. Here in the ball milling, you put big balls of ceramics or steel, and you mix it with your material, and you start to rotate it. And by rotating the machines, the balls crush to each other and form particles and powders and then nanoparticles. If you do it in the right way, the balls and jars which used for this techniques can be made from steel. You can see in left. It can be from ceramics. You can see in right. So we have some ceramics in right, and we have uh, some other steel uh, made balls in left. It depends on your applications, but usually the ceramics one are better and more expensive because they produce less impurities in your material. In the steel one, you may have impurities. You may have lots of impurity in your material, but in the In the left hand, in the right hand, you have a small amount of the impurities. You can add also some additives to your particles or to your vessel. It can call the surfactants or wet media. The wet media, the liquid you add, helps to particles to separate from each other, so they do not stick to each other. The particles you form can, if you do it in a dry manner, they might have stick to each other. But if you add some soap or some surfactants or some ligands, they can get separate. A very simple surfactant in milling technique is soap. So they cover your particle, and if you use water, it's the best option. So surfactants usually have long molecules. So there are some surfactants with different ions. For example, it can come with the sodium, it can come with the ammonium. The surfactants can have also polar heads. They can be large alcohols. They can have polar head and a non-polar tail. They can have amine base. They can have sulfur base, and it's depend on the chemistry of your material. They will stick to your sample. Also, surfactants which cover your material can be antibodies. Can be very complex molecules. Uh, It's depend on you and your study which surfactants you need or why you add surfactants. It's all depend on you. Okay. You can use different wet medias for um for doing milling. You can use polar wet media, or you can use uh, non-polar like a hexane. One very common media is water. It's cheap, it's available everywhere, but you should be careful about using the water because water is not suitable for milling many materials. It's good for some material, but it's good maybe not suitable for many materials. You should consider which material you want to mill. Usually, the ductile materials like metals are very hard to ball mill because when you ball mill them, they will stick to each other. But if you have a brittle material like a ceramic or oxides or glass, they are breaking very easily. So you can make a powder or a nano powder of them easily. So if I ask you a question, which material is easy to ball mill? And there are three metals: copper, aluminum, and then I ask zinc oxide. Which one is better for you? Which one can be powdered by milling? This is an example. Which one? Which one? Which one? I'm back. So when we do wet milling, when we do ball milling, it's better we use brittle materials. Metals hard to grind because they are ductile. So when you force them, they won't break easily. So zinc oxide is the best material that you can mill. The other one is hard to mill. So the other point and parameter you should be careful about is the time. When you do ball milling or wet ball milling or wet grind part, so you reduce the size of your particle first, and then after reduction, uh, you will have a media, okay, of your particle. This can be nanoparticle. If you continue, if you continue more, your particle will stick to each other again. So they agglomerate, and according to that, they grow bigger and bigger again. So it's very important that you do grinding in what we call it in optimum time. Okay, if you do grinding, it's better to do it in uh, optimum time. Okay, it, it does not mean that if you continue your grinding forever, your particle gets smaller and smaller. No, it's not like that. After a while, your particle size will increase again. If you have any question, please ask. Otherwise, we can go say goodbye.